Hello guys, and welcome back to another class of our course about the complete introduction to quantum computing. So today's is our third class of our amazing course about this topic, and we are going to talk about different properties and characteristics of quantum computing. So as you'll see in the next few slides, there are three principal properties that we are going to talk about in this class. So first of all, we're going to cover superposition. Then we are going to talk about entanglement, and finally we are going to talk about interference, which are three really important properties of quantum computing. So once again, I'm not gonna go too much in depth, but I'll try to be as straight to the point as possible so you guys understand the big picture of those properties. So let's not wait anymore and let's jump right into it. All right. So the first element that we are going to talk about today would be the superposition. So that's the first property that is really important in quantum computing. So basically when we are talking about superposition, what we need to understand is that this concept is not like gravity. Gravity, that means it can't necessarily be proved. So yes, we can see gravity, but once again, it can be proved with different laws. Indeed, this concept means that a particle can exist simultaneously in two or more states, and those states can be at the same time. So basically, two or more states and at the same time. In other words, if we take a qubit as an example, it will exist as 0 or 1. So as I said, it's the same thing as a bit. But it means it's a superposition of two states because it will not only exist as 0 or 1, it will exist as both of them. So in other words, to understand this, when it's observed, it has only one value. But when it's not observed, it could be 0 or 1. So basically, it's in both states. But the second that we observe the qubit, it will be 0 or 1. But not only this concept exists in quantum computing, we can also find it through nature. So basically, it's in nature as well. We can, for example, talk here about different chemical reactions or molecule formations that happen. So basically, it's hard for us to observe because of the quantum, it's hard for us to observe the quantum superposition because once again, it happens really, really fast. So let's take a basic, technical example or natural example. So let's talk about the molecule H2O. So this is a molecule of water that is composed of one atom of oxygen and 2 of hydrogen. And basically, the oxygen will share its electrons with the atom of hydrogen. So once again, this is basic chemistry. And but in reality, the shared electrons are the same, are at the same place at the same time within the atom of oxygen and the atom of hydrogen. So in other words, it exists at both places. So this could be one example in nature. So basically, the atom of the electron of oxygen will exist in the hydrogen as well as in the oxygen. The electron of the electrons that will be left behind when this when the atoms of oxygen will come in reaction with the atoms of hydrogen. So basically, we will have 2 electrons that will be left behind, and those electrons, they will be in superposition because, as I said, they will be at 2 places at the same time. So in summary, if we talk about superposition, it will simply refer to the fact that an element can exist in multiple states or places at the same time. So basically, this would be for superposition. The second concept that we are going to talk about today will be entanglement. And basically, what exactly is entanglement? So personally, how I see it, it's a physical phenomenon that can happen when a group of 2 or more elements interact or are generated or have the same proximity in space in a way that the quantum state of each element of the group can't have an independent description of the state of the others. So basically, entanglement is one of the main features of quantum computing and as well as quantum physics. So when we talk about an example of when we talk about an example of entanglement, what we can talk about will be, for example, the two spinning electrons. So let's say we have, for example, two spinning electrons, and one is spinning up and the other is spinning down. So basically, if the two electrons are entangled, this will mean that the probability of one electron spinning up will directly affect the probability of the other electron spinning down. In other words, whatever you measure for one electron will give you the opposite measure for the other electron. So basically, if something happens to one electron, what happens to one electron will be in direct correlation of what happens with the other electron. So this is what you guys need to understand around this concept. Finally, the last concept that is really important in quantum computing will be interference. So how we can see it, it's not simple. It's a bit complicated, but it's a byproduct of superposition. So basically, in other words, that is what allows us to bias the measurement of a qubit toward a desired state or set of states. In other words, it's the ability of two waves passing through each other to mingle, so basically to work together, or it's similar to the way that the ripples communicate in water with each other. So basically, and as an example, what I find it as an example, it could be an interference pattern of light and dark on a screen that will be illuminated by light from two sources. So basically, once again, this is a basic example of interference. So yes, those concepts might seem a bit complicated and really general, but don't forget that currently we are at the beginning of quantum computing. And basically, those concepts are, once again, I try to explain it as simple as possible, but they are way more complicated than I explained it. And there are huge mathematical concepts behind those three really important concepts. But for now, just understand that those three concepts are pretty important in quantum computing. So as I said, first of all, we have superposition, then we have entanglement, and finally we have interference that are really important in this, in the application of quantum computing and everything that is around this type of computing, as well as mechanical physics and everything that is around it. So that's it for this class, guys, and see you all in our next class.